And we're back. So everybody following along at home, this is the warm-up. Go ahead and pause and then play whenever you're ready. But the first thing that I want to do is start by asking any questions on the homework. It could be from the book pages. It could be from the worksheet. Doesn't matter. Yes, please.
Can we go over 18?
Yep.
It asked what's the domain and range, but there wasn't a picture, so I didn't quite understand how to do it.
It didn't need a picture. It needed an equation. It needed you to create an equation. Let me show you what I mean. So it says, so you're basically talking about part B, right?
Right.
Okay. So it says a taxi company charges an additional fee of $2.80 plus $3.50 per mile traveled. That is enough information to tell us the equation. Y is equal to 2.80 plus 3.50 x, where x is the amount of miles traveled, which we would have talked about in part A, right? X input is the amount of miles traveled, output is the total cost. Then it says you have enough money to travel at most 20 miles. Now, could I travel for 10 miles?
Yeah.
Could I travel for 12.5 miles?
Yeah.
Could I travel for 13.25678 miles?
Yeah.
Yes. That means that this is continuous. So here's part B. I have to talk about the domain as a continuous line from 0 to 20, right?
Mm-hmm.
That's my continuous domain, anything between 0 and 20. So then my range would therefore be, okay, if I went 0 miles, I mean, that doesn't really make sense, but if I hopped in and hopped out, they would still charge me $2.80 just for getting in the car. Right. But then why would you call a cab? But then $3.50 per mile. Okay, if I only go up to 20 miles, I got to figure out what the 20 is. 2.8 plus 3.5 times 20. That biggest charge I could have, $72.80. Does that make sense? So I didn't need a picture. I needed an equation.
Oh, okay.
Yeah. What other questions do we have on the homework? Anything on the homework? Yes.
17.
Number 17. Same type of deal here. A cell phone plan costs $30 for each line. Part A says identify independent and dependent and talk about whether it's a function or not. So the phone plan depends on how many lines you have, right?
Mm-hmm.
So our input is the amount of lines, phone lines, amount of them. I should have put amount of, always reference something numerical. Amount of phone lines. Okay, if I change the amount of phone lines, what's that going to cause to change? The price. And remember, I kept saying on Friday, the price, if there's something referencing money, something referencing cost, that's usually your dependent variable. Okay, now, is that a function? If I say my input is 3 phone lines, there's only one output, right? There's only one price. It's not like they're going to charge me 2 different prices. I got one phone line. Okay, so that is a function. And let's try to create an equation based on that function. Well, it's $30 per line, right? Okay, y is equal to 30x. Per means to multiply. $30 per line. And if x is the amount of lines, it's y is equal to 30x. Now, I then say in part B, you can have a maximum of up to 4 lines on a plan. Okay, for my domain. Would it make sense if I had 0 lines on a plan? No. So my first possibility, what about 0.5 of a line? No. My first possibility is 1. Can I have 1.5? No. Next possibility, 2, 3, and then 4, because I can have up to 4 lines. So this is one of those discrete examples. Single, solitary points where decimals don't make sense. All right, now we find our range just by plugging those values into the equation. So if x equals 1, then it's $30. If x equals 2, then it's 60. 3 times 30 is $90. 4 times 30 is $120. And that's my domain and range. All right. Any other questions on the worksheet or the word problems? Okay, let's talk about two more examples of domain and range. We've done a lot of them, so now this should be mastery by now. Like, I had people sitting there, and I hope I didn't really check very much in this class, but I had people sitting here thinking, oh my gosh, I have no idea what I'm doing with domain and range. That is a problem, because we've done it for 3 days now. You need to start learning how to do this stuff, and you need to start kind of refreshing your memories every time we do this. It's okay to be like, oh, that's right, I didn't remember it, now I remember it. Look back and see. But it is not okay to just sit there and go, ooh. No, that's not okay. It's not okay to just sit and not know what you're doing. You need to get help. Okay? So find the domain and range. First thing that I want to do is describe the domain. Remember, the domain is any x values. So looking left to right, here to here. Left to right, -7 to +5. I should have talked about it, but is this continuous or discrete? Continuous, right? I can draw this line without picking up my pencil. And then for my range, it's bottom to top. So how far low does this go? -2. How far up? +5. So there's my domain and range. And another example, just like it, with the second one here. It's just got this weird U-shaped function. All right, so here to here is my domain. My domain is -7 to +3. My range is here to here. -4 to +5. Yes?
How do you know which way to put the inequality?
They're always less than or equal to.
Always?
Always,
Yeah.
yes, because they are and inequalities. They are always less than or equal
So
to.
that's the left side, the y is like equal to -4. So when the 4 be less or greater than or equal to y. You just said they're always less.
No. Because you want to say this is an and inequality that references all numbers in between those two values.
Oh.
Okay? Because you got to read it this way. You almost have to read it backwards. Y has to be bigger than -4, and y has to be less than 5. Does that make sense?
Yeah.
That's why they always have to be less than. Always, for an and inequality. If they don't turn out to be less than, then it's like a no solution type thing. Okay, last example here. Netflix charges $7.95 per month. Is that a function? Identify independent and dependent variables. Okay, what is my independent variable here? Can anybody tell me? Gio?
795.
Nope, it's
No.
not.
How many months?
How many months? There you go. How many months? Amount of months. And my dependent variable, if I change the amount of months, what does that cause to change? Again, we're talking about price. We're talking about cost. Total cost. Money. Okay, is that a function? If I input an amount of months, could I ever possibly get two different prices? No. Something's wrong with that company then. So yes, this is a function. Let's write the equation. Well, if it's $7.95 per month, no other charges, 795x, where x is the amount of months. All right, if I can subscribe for 5 months or less, what is the domain and range? So what is the domain here? What is the domain? If I can subscribe for 5 months or less, what is the domain? Nathan?
Months?
Yes, but I'm talking about numerically. What is the domain?
Oh, 1 to 5. 1, 2, 3, 4.
There you go. That says it better. Yeah. Because if you say 1 to 5, it almost seems like I could say 4.5. And can I have Netflix for? Can I get Netflix for 4.5 months? I mean, I could, but how much would they charge you for? 5 months. They're not going to prorate it. The prorating is that term prorating means like, okay, then they would charge you like 4.5 months. They would prorate the charge. They would like take it half for the month. Some people will do that. Now, for my range, I've got to plug those values in. So 1 month is $7.95. 2 months, I think I got them up here. Oh, not anymore. 2 months would have been 2 times 7.95 is 15.9, 1590. 3 months. Okay, this is 4 months, 31.8. And then 5 months was, still my calculator there, 39.75. I just got to calculate 3 months.
3 months is 23.85.
She's got my back. 23.85. Good. Again, those are the only possible charges, right? That's it. Could I have anything above or in the middle of those prices? No, because it's only single solitary amounts a month. That's a discrete example. Okay. All right. Let's hand out the guided notes here. Okay. Hey guys. And I've said this first period, and I want to get it on the video too, just in case anybody's out there listening. Hopefully you're all out there listening if you're absent. I want to point your attention to this sign. Everybody look up there. What's that say?
Nothing will work unless you do.
Yeah, nothing will work unless you do. I talked about this first period. There's a lot of people not doing their homework. There's a lot of people not doing your work. Now, I got to be honest. Those of you, you've been able to like kind of skate by a little bit in this first 9 weeks because, thinking back to the stuff that we did in first 9 weeks, solving equations and inequalities. Solving equations and inequalities. Did you guys do that in middle school? Yes. The answer to that question is yes. So you had learned that before. You had learned solving equations and inequalities in middle school. I know for a fact you did because it's in their standards. We're going to start doing things that are brand new. Things that if you don't practice it, you are not going to understand it. If you don't work, it's not going to happen. Okay? It's not like that light bulb moment is not going to happen if you don't wire your brain successfully. If you don't train your brain to get wired correctly, you're going to flick the light switch and nothing's going to happen. The lights aren't going to be turning on. You have to be doing your homework. You have to be staying on top of things. Now more than ever, if you got a bad grade in the first 9 weeks, start fresh second 9 weeks. Okay, if you fail the first 9 weeks, that doesn't mean you're going to fail second, third, and fourth 9 weeks. That just means you need to do something different. That just means you need to change your behavior. If you got a D in the first 9 weeks, doesn't mean you're going to get a D the rest of the year. If you got a B, doesn't mean it's going to be a B. You could get an A. Awesome. If you got an A in the first 9 weeks, doesn't mean you're going to get an A the rest of the year. Okay? We've done a lot of review material the first 9 weeks. We're going to be doing a lot of new things the second, third, and fourth 9 weeks. So you cannot rely on things that you learned in middle school. Okay? Yes, question.
If you're mostly, let's say, like you caught up and you're done with your test, is your grade right now, you're standing first 9 weeks?
Yeah. Yeah, the only thing that could change it is the homework grades that I will take this week up until Wednesday. That's it. Okay. That means if you need to turn in your late homeworks, get that done, folks. I know you had 2 late per 9 weeks, and I wanted them before the quiz. But if you haven't turned those in, and you still got some late homework to turn in, do it. Okay. Every little bit helps. All right. So why do I say this right now? Because I will tell you, if you don't do this homework assignment tonight, if you don't actually try on this homework assignment, it's gonna be rough. Okay. Also, this is something that is new for you guys. This is something, maybe not the front page, but probably the back page. This is something that you have not really learned yet, and something that truly I don't expect you to master right now. Just like you walk into Spanish class for the first day, are you fluent by the time you walk out of that first class? No. You've got to learn these things, and it takes a little bit of time. Like this whole understanding functions on the back, yeah, that takes some time to learn. But you got to introduce it sometime, and now that's what we're doing here. A lot of people are getting frustrated first period, like, I don't get this. It's like, oh, yeah, okay, I get it. Yeah, you don't get it. It's the first time you learned it. Now, this first page, though, however, that first page should probably be review for you guys. You guys know the terms X and Y-intercept? Yeah. Well, all we're going to be doing today with this front page is just taking a look and seeing, okay, can you identify an X and Y-intercept based on the graph? This should be pretty easy. Can you identify where an X and Y-intercept is based on a graph? The only catch is I want us to train ourselves that when I'm asked for an X or Y-intercept, I want to give a coordinate. The coordinate 0, or something, 0 for an X-intercept, and 0, something for my Y-intercept. Okay? Remember, the word intercept means to get in the way of, right? Or to cross paths of, right? That word intercept means to cross paths of. So if I'm talking about the Y-intercept, I'm saying, where does the Y-axis intercept my line? Where does the Y-axis get in the way of my line? That's what I'm looking at here. Okay, take a look at our first example. Estimate the intercepts of the graph and the graph of the graph of each function. Do I care about what the equation of the line is right now? No, but we will definitely care about that by the end of this chapter. By the end of this chapter, you'll be able to tell based on an equation what the intercepts are as well. All right, so where is the Y-intercept? Where is the Y-intercept? 2. That's the one. The reason why I start with the Y-intercept is because usually that's the one that's a little bit more familiar to you guys. He said 2. I want us to shift our thinking a little bit to make it a coordinate. 0, 2. Now, if you just gave me 2 for right now, I would be okay with that, but I want you to start training your brain to think of it as a coordinate. It's a location. It's a coordinate. I always abbreviate intercepts as Y-int and then X-int. Now, what's my X-intercept? That's the one that's probably a little bit more unfamiliar to you guys. That's okay. It's just where it crosses the X-axis.
4/3.
Oh. I wouldn't say 4/3. Don't look at it in the equation. That's the slope of the equation. Look at it actually on the graph. Where does it hit on the graph? 1.5? Negative 1.5. Negative 1.5. Right? It hits right here. Remember, this is your X-intercept. This is your Y-intercept. Where it crosses the Y-axis is your Y-intercept, where it crosses the X-axis is your X-intercept. Good. Now, by the end of this chapter, we're going to be working a lot with lines. But later on this year, we're going to be talking about quadratics, which is what you see here. This is an example of a quadratic. We're going to spend an entire chapter on quadratics. Notice here, look at your Y-intercept again. Let's start with the Y-intercept because, again, that's a little bit more common to you guys. Let's start with my Y-intercept. What is my Y-intercept? What is my Y-intercept? Where does this function cross the Y-axis?
-3.
-3. 0, -3. Okay, good. Now, if I talk about the X-intercepts, oh, that's an N in there. Sorry for my poor handwriting. If I talk about the X-intercepts, notice that I'm making that plural. Does it cross the X-axis once? Crosses it twice, 2 places. We're going to have problems. We're going to have examples that cross twice. They cross 3 times. They cross 4 times. Could cross an infinite amount of times. Okay, we're going to have problems where it crosses a wide variety of times. Every parabola, well, I shouldn't say every, most parabolas cross the x-axis twice at 2 locations. So our first location looks like it's right here, and our second is right here. So I want to call it 1, 0, and then I'll put a little semicolon, 3, 0. You don't need the semicolon, just showing that that's what formal. How do you write it formally? But please, again, start writing it as a coordinate. Start writing it as a coordinate. All right. So flip it over to the back whenever you're done with that. What we're going to be talking about the rest of the day is how do we talk about functions? What are some key things that we can visually see based on a graph? Because that's one of them, right? Isn't the intercept one of those things that, like, if we look at a graph, that's what we can identify? On the back, what we're going to talk about is some more intricate things, some more nitpicky things on how to look at a function and talk about it a little bit. First thing is whether a function is positive or negative. Whether a function is positive or negative. Well, I wish I could have printed these guys' notes in color because it looks so fancy up on my screen, but then when you look at your paper, it's all black and white. I'm really sorry about that. So if you want to use highlighters, if you want to put different colors on there, you want to mark it with colors, you do you. Here's what I will say. Look up at my screen. Where is the function positive? Everywhere where it's blue. Here to here, here to here. So basically above the x-axis. Where the y values are positive, where the output values are positive. Okay, where is it negative? Here and in here. Where the output values are below 0, where the output values come out to be negative. Now, how do we talk about where that happens? We talk about it in terms of its x value, in terms of left to right. So we would say for every x value to the left of this point, it's negative. For every x value in between here and here, it's positive. For every x value in between here and here, it's negative. For every x value above here, it's positive. Now, the next thing we're going to talk about is increasing or decreasing. Increasing or decreasing. You know what I like to think about here? Is if I put a tiny little roller coaster on that line, and it's going up the hill, if it's on that chain, it's going chunk, chunk, chunk. If it's going up the hill, then the function is increasing. If it's going down the hill, that's decreasing. Okay? Increasing is going up the slope, decreasing is going down the slope. Increasing is going up the hill, decreasing is going down the hill. So it will change at every peak or valley that there would be in the function.
Can you look at it left to right or right to left?
Always read it left to right. I was going to point that out. Always read the functions left side to right side. Always read the functions from left to right. So as I go from increasing to decreasing, look here. I put my little, can I draw the tiniest of tiny little roller coasters on here? Here's my little stick figure dude with his hands up. That's pretty good, actually. I'm pretty proud of that drawing. So as I take that dude and I make him go, yada da 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 da, woo! Uh-oh, he's gonna stay like that. He's like popping a wheelie now. Whoa! Decreasing. And then he goes chug, 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 increasing. Right?
Up to the sun.
So every time that guy in the roller coaster is going up the hill, it's increasing. Every time it's going down the hill, it's decreasing. And again, we talk about it in terms of its x values. We would say, okay, from every x value, from here to here, from here on downward to the left, that's where the function is increasing. Every x value in between those two blue lines, that's where the function is decreasing. Everywhere where the function is increasing on the right side, every x value above that line. Lastly, we're going to talk about end behavior. And guys, it's exactly as it sounds. What's happening on the end of the graph? I'm disregarding everything that's happening in the middle. We've already talked about it. But now what I'm saying is what's happening on the end of the graph. And guys, there's really just two questions that you've got to ask. Is it going up or is it going down? That's it. Is it going up or is it going down? Let me try to demonstrate this for you. It's an easy question to ask, but the notation is super weird. Okay? This is what the notation that you will see. Y. Basically, every single problem, please look up at my screen. This is not in your guided notes right now. Every single problem will have this piece. Oh, I wanted purple. This piece in there, pre-written for you. All you have to decide is what to put on the end. So let's kind of translate it. Let's translate it from our math language to our English language. This says x arrow positive infinity. So meaning, as x gets bigger and bigger and bigger. So what direction is that on a number line? On the right. Okay? So this is saying on the right. Oh, I shouldn't put an arrow. On the right, what do the y values do? Does it go up or does it go down? That's all I'm asking you. Does it go up or does it go down? And then, well, yeah, that one goes up, you're right. And then this says as x goes to negative infinity. So as x gets getting smaller and smaller and smaller, what direction is that?
Left.
On the left side. On the left side. So really, that's all I'm asking you. On the right, what is happening? And then on the left, what is happening? And here's how you answer it. If it goes up, you say positive infinity. If it goes down, you say negative infinity. So here's how I would answer this one. What's happening on this function on the right side? Is it going up or down?
Up.
Up. Positive infinity. What's happening on the left side of that function? It's going down. So I would say negative infinity. Okay? That's how you answer the problem. There's going to be a blank there for you every single time that you should either say up or down. So positive infinity or negative infinity. Let's do it. Oh man, I've only got 6 minutes to do one of these problems. I told first period I would have this on the video. We better get student folks. All right. Approximate when the function is positive or negative, increasing or decreasing, then describe the end behavior. Okay. So let's say positive. When is this function positive? Well, let me highlight it for ourselves here. The function is positive from there to there. Oh, sorry, all the way down to here. That's when it's above the x-axis, right? So where's the breaking point? When x is what? When x is 3, right? So everything to the left of 3, below 3, that's when it's positive. Okay? Well, then when is it negative? When x is bigger than 3. Okay? Every x value bigger than 3, it would shoot below the y-axis. Okay, so that's positive and negative. Let's talk about increasing versus decreasing. Let's talk about our little dude on the roller coaster. Oop, gotta get this guy out of here. Okay, so I am going to highlight everywhere where it's increasing. Okay, this starts off by decreasing, reading it from left to right. Decrease, decrease, decrease. Oop, change. There is my increasing section. It autocorrected to a straight line. So now we say from 0 to 2, right? From the x values of 0 to 2, the function is increasing. Well, how do we write that? Oh, yeah, it's that compound inequality. It's that inequality. It's because this is continuous, right? So I've got to use my compound inequality. Well, if it's increasing from here to here, well, then it's got to be decreasing everywhere else. Decreasing here, decreasing here. Okay, so every x value below 0, or every x value above 2. And now we talk about our end behavior. Now we talk about our end behavior. Now you have this pre-written for you. Okay, on the right side, because that's what it says first, right? As x goes to positive infinity. On the right side, is it going down or up?
Down.
So we write negative infinity. On the left side, is it going up or down? Up. So we write positive infinity. Okay, I want to do one more real quick. I know we've only got 3 minutes left in the bell. If I don't hand out the homework in time, I'm going to set it right here. Just pick one up as you leave. Okay, example B. Okay, let's go positive and negative. Okay, when is the function above the x-axis? From here to here, right? Well, that's the x values from 1 to 3. Oh, sorry, I wrote 0. From 1 to 3. Well, then it must be negative everywhere else. So everywhere below 1 or above 3. Notice that I'm not saying equal to, because that equal to, it would be 0, neither positive nor negative. Okay, so let's see increasing or decreasing. Let me erase away this, and I'm going to say, okay, up the roller coaster, up to here. That's when I meet my peak, right? So everything to the left of 2 is increasing. Everything bigger than 2, decreasing. So x is greater than 2 for my decreasing. Now, end behavior is going to look like this. As x goes to positive infinity, as x goes to negative infinity. You have that pre-written. Oh, look, what's happening on both my left and my right side? It's going down. So we would write negative infinity for both. Woo!
Oh,
That was fun, folks.
Good job. You did it.
Well, that's an issue. You should be more late.
I thought the notes were enough.
Well, it makes you talk and do your homework. Stop. That makes your dog happy. Oh, here, see me for a worksheet. Here you go, if you haven't already. Here you go. I'll be coming around the mountain. Yeah, did you get one? Brad, did you get one? You get one? Yeah, you did. Whew. All right, now I can stop my video.
No, you just did a lab. Are you going to do a lab?